right, today we are going to talk about 2.2, which is the first and second derivative rules. So our idea today, hold on, let me finish writing. I always think I can multitask, and it turns out I can't. I think you've realized that through these videos this semester. All right, so let's talk about the first and second derivative rules. So our idea in the next two sections, well, actually 2 to 3 sections, is we're going to look at how can we describe things about a function using the derivative. So what can the derivative tell us about a function? So I just want to, and I hope you've read this already, but I just want to make sure you kind of understand what we're talking about today. And let's just kind of let me show you a quick example of a function maybe, and what might how we can maybe look at this function and what's happening to this function. So let's say I have a function that does something like this. Okay, so this is my function f of x, this is x, this is f of x, of course, or my y-axis. And I just want us to talk about what's happening to the derivative. So remember what the derivative is. The derivative gives us the slope of tangent lines. So if I look at my tangent lines here, slope of tangent lines, okay? So I'm just going to, and right here I'm going to go underneath, just pretend that these are lines. Oh, that one was bad. Sorry about this. You have to, when you're in my class, it's a lesson in imagination, if nothing else. So let's look at, what I want to talk about is I want to talk about what does the first and the second derivative tell us about the slopes of these lines here. And if we look at this graph here, I want to point out a couple of things. So I want to point out this point right here, even though I didn't do a perfect line right there. What do you notice about the slope of, well, what do you notice about that line, first of all? That line is horizontal. So what does that, remember with the slope of a horizontal line there? Slope of a horizontal line is 0. So right away I can see I have a horizontal line right there. So what do I know about the derivative at that point? It's 0. Same here. If I come down, oh, good enough. What can I tell about the slope of the tangent line there? It is also 0. So that tells me that my derivative is 0 at that point. What does that mean again? That means that my function is not changing at that moment in time, which kind of makes sense, right? Look at what my function's doing. Increasing, increasing, increasing. At this moment in time, it kind of stops increasing, and then it has to switch to decreasing. So at this point right here, that means my derivative is 0. So then it starts going decreasing. So what I want you to pay attention to is, so we talked about this increasing and decreasing in 2.1, and let's look at my tangent lines. The slope of this tangent line here is positive. Positive, then it goes to 0. Then look at what happens. What's the slope of that line? Yes, I imagine that you are telling me, Sarah, that's negative. Negative slope. I still have a negative slope. Not quite as negative now. Still negative slope. I go to 0, and then look at what is happening. Positive tangent line slopes. Okay, so positive slope, 0, negative slope, negative slope, negative slope, 0, back to positive slope. And what do you know about this interval here? Here my function is increasing over this interval. Here my function is decreasing, right? My function values are getting smaller. And over here my function is increasing. So what we can then associate with that is over the increasing interval, what do I know? That f prime of x is positive, right? That's what that's showing, that those derivatives are positive. Another way of saying positive is it's greater than 0. I tell my students you should be like, instead of, some inspirational person telling you stay positive, we should just start saying stay greater than 0. Stay positive. I have a lot of really, really dumb math jokes, so if you ever take me not online, don't worry, I'll share them with you. Look at what happens here. Notice all of these slopes. What are these? These are negative. Another way of saying something is negative is saying that f prime is less than 0. And then again, where are we positive? That's saying that f prime of x is greater than 0. So I hope that made sense in the book. I know reading mathematics is not always the easiest, so I might start making these lectures just a little bit longer to maybe give you more of a lecture feel with some of these videos. And of course, you can always fast forward through some of this and get to the examples. I don't think it's fast forwarding anymore, is it? That shows my age when we had videos. Anyway, let's move on from that topic, my age. And this is basically what the first derivative test is telling us, okay? We are going to be, when we are increasing, what does that mean about our derivative? that it's positive. When the function is decreasing, what do we know about our derivative? It's negative. And then over here, same thing. So what the first derivative test then tells us, so let's write this down. You should be keeping notes. You should be, that's one way to go back and know what's in the, and I write for you in each week, I tell you what boxes to write in your notes, what examples to write in your notes, and that's what you should be doing. So the first derivative rule, here's what the first derivative rule says, which we kind of saw here. If f of x is increasing on an interval, okay, we'll just say I, okay, so over an interval, then what do I know? Then I know that my derivative, f prime of x, must be positive on that interval. Okay, so anytime I would take the derivative of f and I'd plug in any number, let's say in this first interval right here, when I plug it into the derivative, I'm going to get a positive number out. All right, 2, likewise, if f of x is decreasing, on an interval I, then what do I know about the derivative? Then I know f prime of x is less than 0, right, is negative on that interval I. Okay, and so that we can kind of see from the graph above, and that first derivative rule is going to be very important for us, especially when we start talking about finding maximum and minimum values. So if you look here, do you see how I have a relative maximum here? I have a relative minimum here. And the big thing to notice here is at this maximum, look at what the derivative does. It changes from positive to negative. At this minimum, it changes from negative to positive. Also, what do I know about the derivative at that max or min? It's 0. So that's going to be important for us in the next section. So let's talk about the second derivative. So let me get rid of this one, and let's go with layer 1. So let's graph this same. I want to graph this same kind of function. Doesn't have to be perfect, right? Things in life rarely are perfect. So, although I have to say that mathematics is perfect. Mathematics is the perfect science. Now, when I draw mathematics, it may not always be perfect, but. So, oh, just like that. Look at that. Yep. So let's look at that same kind of function here. And what I want to look at again is I want to look at what is my second derivative telling us. So remember, what is the second derivative? The second derivative is really just the derivative of the first derivative. We saw that in that last chapter, right? So look at what the second derivative is asking us to look at. We're looking at the rate of change of my derivative. So again, if I look at these tangent lines, oops, I want a different color there. Whoops. So if I look at these tangent lines, again, I have positive, positive, and then look at what's happening here. I'm just going to give up here. Okay. Do one more on this side, and then I'm going to come below here. Maybe not quite as negative. I go to 0, and then I go positive again. So what I want to show you is what the idea of the second derivative gives us. Okay, so let's look at, now I know, so this is a pretty large positive slope. I'm going to put a big plus because it's a pretty large positive slope. Like it's pretty steep, right? Maybe it's like 2. And then look at what happens. It starts getting not quite as positive. And even here it would be not quite as positive until I hit 0. And then, so I'm pretty positive, and by pretty positive, I just mean I'm a bigger number. I'm a large positive number possibly compared to maybe the slope of this guy right here, right? If I look at the slope of this line right here, do you see how that slope maybe is this guy's a little bit flatter than this one here. And so as I start looking at this, then I get to 0, then it gets to be, so I'm positive, decreasing to 0, right? And I'm kind of negative here. I'm really negative here, right? And then I start getting maybe not quite as negative, even a smaller negative. Maybe this is a -2 right here. Maybe this is only a -1.5. Maybe this is a -0.5. I get to 0, and then I get positive again. I get even more positive here, and then I get even bigger positive here. So what you notice with the slope of the tangent line, again, what is the second derivative asking us? It's asking us, how do the slopes of the tangent line change? So here's what the second derivative does for us. If I look at this point right here, this is going to be where the second derivative is equal to 0. And here's the reason why. Here, notice the slopes of my tangent lines are getting smaller. Like let's say that this was slope 2, and maybe we'd estimate this to be 1.5, and then maybe the slope of this guy's just 1, and then I get to 0, and then I get to maybe a -1, right? And then I get to maybe a -2, but then at this moment right here, I get from a -2 and I get not quite as negative. Maybe I'm back to a -1 again, then I may be at -0.5, then I'm at 0, then I'm at maybe a +0.5. Again, these are just estimates. Then I'm at 1, then I'm at 2. So if you notice this right here, this tells me that my derivative, my second derivative, is less than 0. Okay, look at the slope of my tangent lines are decreasing. That means the rate of change of my first derivative, which is the second derivative, is less than 0. Over here, what is this saying? That the slope, that my slope is getting bigger, which says the rate of change of my derivative is getting bigger. This is what we call over here concave down. We've talked about that before. We've seen that before, right? That's down, concave down, and this right here is concave up. Okay, so this is the second derivative rule, and let's write that down, and then I'll maybe give you a recommendation on how to remember that. So second derivative rule. So here's what the second derivative rule says. If f of x is concave up on some interval I, I'm just going to say I, then what do I know? The second derivative of that function is greater than 0 on I. It's positive. That's all that's saying, right? Greater than 0. Stay greater than 0. Although sometimes you're less than 0, I get it. Sometimes I'm negative. You know, you have days like that. If f of x is concave down on I, concave down, that's a frowny face, right? Then we're negative. Then f double primed of x is less than 0, negative on I. Okay? All right, what does it mean if it is equal to 0? Well, if it's equal to 0, we've talked about this. This is what we had called before. This is where the inflection point happens. Okay, so again, second derivative rule, what I think about positive, I think of bank accounts sometimes when I think about this. So this might be silly, but it might help you think about it. Positive, concave up, I have a smiley face because I have positive money in my bank account. Negative, if my second derivative is negative, if I have negative money in my bank account, I am sad because I don't have any money. I've been a college student. I get it. I've been there. All right, let's look at how to actually use this stuff. Later on, ooh, sorry about that. We are going to talk about how we can use this stuff to actually find maximums and minimums. That's going to be the big thing, and how we can actually sketch graphs of functions, which I'm not going to focus on too much, but I want to do a couple of examples here. This is the big stuff on this section, but there's a couple examples that I want to do from your homework that can be just a little bit tricky. So I would like to do one of those examples for you, and then hopefully that will that'll kind of help you know what to do here, especially this one. This is always a doozy. So here is what this one says to do. This one says, let me get the exact wording here. I know I'm not ready. Hold on. This just says sketch the graph of a function that has the properties described. So what I want to do, number 11, you have to do number 10. I want to sketch the graph. So this is just number 11 in your book. Pause the video, write this down in your notes. All right, so here are the properties that I want to have. All right, so let's draw. This could be interesting with me trying to do this by hand on my tablet here, but you know what? Might as well try it, right? And so let me give myself, so these are the points. Look at what this says. 0, 6, 2, 3, and 4, 0 are on the graph. So that's easy to do. So I can definitely 1, 2, 3, 4, 5. I can easily graph those. That doesn't have anything to do with calculus. This is just, you know, algebra. I hate saying just algebra because a lot of times the hard part in calculus is the algebra, as you have probably seen. You know, when you do those definition of derivatives and stuff. Okay, so here's what I know. I know that 0, 6, 0, 1, 2, 3, 4, 5, 6, 2, 4, 6. I know that 0, 6 is on the graph. I know that 2, 3 is on the graph. And I know that 4, 0 is on the graph. This is all I know so far. What else do I know? I know that the derivative of the function at 0 is 0. So what do I know at 0? I know I have kind of a horizontal tangent here, right? That's what that's saying. So I'm going to draw a line. I'm drawing a tangent line. This is not going to be my actual graph, but I know I have a horizontal tangent line because this is saying when x is 0, remember that's an x value, I know the graph, the slope of my tangent line is 0. What else do I know? That the derivative of, or excuse me, the slope of the tangent line when x is 4 is also 0. So I know that I have a horizontal tangent line right here. Okay, so those two, so I've done this, I'm going to cross these off as I do them. I've done this, I've done this. So I know that I have a horizontal slope. Here's what I don't know. I don't know if the graph comes up like that here or if it goes like this here, but I know one of those two things is going to happen. And here's where it's going to tell me that. So this says the second derivative of the function is less than 0. That means it's negative, which means it's concave down. Okay, for all x less than 2. So from here over, I know I'm going to be concave down. Ooh, pretend. And then this says that the second derivative at 2 is 0. That's good. What does that tell me? That we have an inflection point, right? What does that mean? I change concavity at 2. And then look at this. This says the second derivative is greater than 0 for x greater than 2. So if I'm on this side of it, I know I'm going to be concave up. Okay, so here's what this graph is going to look like. Let's do a different color. I know I'm concave down on this side. So I know that my graph must, and your graphs will look a little bit different than mine probably, come like this somehow. And I'm just going, I know it's concave down this whole time. So I know this has to continue down. It can't come back up, right? Or else I wouldn't still be concave down. Then what do I know? I know my second derivative is greater than 0, or this is positive, so that means I'm concave up. So this guy right here at 2, it must switch. I must hit right here and come up. And that is my graph. Now yours might look a little different than mine. Yours might be skinnier, yours might be fatter based on how you do your x and y axis. But I hope that makes sense, that when I'm using all of these values, that's what the graph looks like. I really like questions like this. I don't know if you care what I like or don't like. Maybe you should care what I like or don't like since I write your exams. I like questions like this because it helps me see if you really understand what these properties are. If you have questions on these, you should do the suggested. You should do number 9 and number 7. Those answers are in the back of the book. If you want to do 8 and 12, do 8 and 12. Send them to me. I am here to help you. Send them to me and ask me to grade them for you. I'd be happy to do that for you. Okay, I just want to do one more quick example and then we'll call it good. Let me clear this all out. So my other example, okay, this is, again, one on your homework. So I just want to do a couple from your that are close to the one that you actually have to do on your homework. So you have to do number 28. Let's talk about number 27. So number 27 says in your book, explain why f of x has a relative maximum at x equals 3. Okay, so at x equals 3, now people, look at this. Notice this is the graph of the derivative of f of x, okay? So look at what's at 3. What is this telling us? This, if you look at 3 here, what is f primed of 3? This tells us that f primed of 3 is 0. So why would we have a relative maximum? Well, first of all, the slope, right, of the tangent line is 0 at 3. That's good. We saw that, and before we saw that if we had a maximum or a minimum, right, then it looked like we had a horizontal tangent line, which meant we had 0 slope. The other thing to notice on here is that look at what happens to our derivative. Our derivative is positive, right, above the x-axis. So our derivative is positive here. It's 0 at 3, and then it goes negative. So that's my other explanation here, too. The derivative, or let's just say, let's get lazy here, f prime of x goes from positive to negative at x equals 3. This means we have something like this. So it goes from positive, so what does that mean? That means my function is going to be increasing, then it's going to go to 0, and so then it will be decreasing. And we'll see this later on, that what is a maximum? A maximum has a part that's increasing, and then it turns around and it goes decreasing. So something like this is enough explanation. F prime of x goes from positive to negative at 3. This means we have this, thus it's a maximum. I would really recommend doing, there are a lot of those that have to do with this graph on page 147. I would really recommend doing some of these. And if you have any questions on that, let me know. Well, I hope you're still hanging in there. It's been almost 22 minutes now. But as always, let me know if you have any questions, and I look forward to doing another video with you.